So this video is all about the real number system. So before we start talking about numbers, we need to be able to sort of categorize them so we can talk about them in a clever way. In the same way that in biology you might categorize animals into mammals and reptiles, and then categorize the mammals into various types of mammals, and categorize the reptiles into various types of reptiles, get a nice little family tree going on. We can do the same thing with the real number system. So it all starts with the real number system. Hopefully I don't need to define what a number is, but you might be wondering, why are we talking about real numbers? What do we mean by real number? Well, a real number is anything that can go on the number line. So if we start at 0 here, and we can count all the way forward to like positive infinity, and we can count all the way backwards to like negative infinity. So a real number is just any number that can exist on that number line. And that might be decimals or fractions or whole numbers or negative numbers or positive numbers. Those are our real numbers. Now, there are other numbers called imaginary numbers, not a joke, and we'll learn about imaginary numbers a little bit later on. But real numbers is the bit that we're going to focus on. Now, I've just moved that over a little bit because I might run out of space if I don't put it over there. Now, the last thing I really need to say about this is the real numbers. Sometimes it's useful to be able to talk about real numbers in your maths, and it might be useful to have a symbol for real numbers. So the symbol that we use is capital R, and I'm sure you can figure out why that is. Now, the real numbers can be split into two broad categories. Just might change the color here. And those two broad categories are irrational and rational numbers. So you've heard the word rational and irrational before. If someone's acting a bit, they're acting irrationally. If someone's sort of following some good logic, they're acting rationally. Now, that's got nothing to do with these words. The way to think about these words is actually ratio null. Don't say it that way, rational, but it's ratio null. And this is irratio null. Again, don't say it that way. The reason we use this word is because a rational number can be expressed as a ratio. So, for example, 2 over 5. 2 over 5 is a rational number because it can be expressed as a ratio. Similarly, something like 7 over 9 is a rational number. But also just something like 6 over 2 is a rational number. And if you're quick, you'll see that 6 over 2 is actually just 3. So whole numbers as well are rational numbers. Okay, so anything that can be expressed as a ratio is a rational number. You can probably guess what an irrational number is, but we're going to get to irrational numbers in a minute. Now again, sometimes it's going to be useful to be able to refer to rational numbers inside of our mathematics. And so in the same way that we can refer to the real numbers by using the letter R, we should be able to use some letter or symbol to refer to rational numbers. Unfortunately, R was taken, so some clever mathematician chose Q to represent rational numbers. Confusing, I don't know, one letter back in the alphabet. I don't know why they decided on Q. Now, before I start talking about the irrational numbers, I'm just going to keep working down from rational numbers. Now, the rational numbers are broken up into sort of two subcategories, and those are the integers and the very catchy title, non-integer rationals. Alright, so an integer is simply a whole number. Alright, so that's pretty straightforward. What might not be so straightforward is the letter that I'm going to choose to represent integers. Bit weird, it's the letter capital. These are all capital letters, Z. I don't know. So again, whole numbers, so it's 2, 3, 4, 7, a million, but it's also all the negative numbers. Okay, I'm not going to go down the non-integer rationals. We'll pick that up in a second. but obviously that's all of the rational numbers that aren't integers. We'll talk about those in a sec. Let's talk about integers, because integers can be broken down into 3 distinct categories. And this is actually not too bad. So the integers can be broken down into z, integer, positive. So the counting numbers, the one you learnt in grade 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a million. Special category, 0 gets its own little branch. 0 is a very special number. And finally, the negatives. -1, -2, -3. Remember, they're still integers, so there's no decimals there. All right, that sort of concludes that particular branch, real numbers down to rational numbers, down to integers, whole numbers, and then the positive whole numbers, 0, and the negative whole numbers. Now, let's just go down this branch, non-integer rationals. All right, so they're rational numbers. Here they are. And there are sort of 2 categories of non-integer rationals. There are terminating decimals. Because when you come up with a rational number, a ratio, sometimes, like 2/5, if you type 2/5 into your calculator, you get 0.4. And it terminates there, it stops, it's exactly 0.4. If I was to type in, let's see, what's another, 1/4, well, 1/4 typed into your calculator is 0.25. It's a terminating decimal, it stops. Now, the other version of a non-integer rational, instead of the terminating decimal, is the recurring decimal. And if I ask you to stop and think 2 numbers, one divided by the other, that gives you a recurring decimal, most of you will probably all think it's the same one. Think of one. 1/3. And the recurring decimal for 1/3 is 0.3333, and it goes on forever and ever and ever. A lot of you will know that you can just write that as 0.3 with a little dot above it. All right, so there's our rational, non-integer rational, so a fraction, but it doesn't give us a whole number. And then they can be broken down into those 2 groups, terminating decimals or recurring decimals. The very last thing we need to talk about is irrational numbers. They come in a few different flavors. We're not really going to do like a whole branch thing. We're just going to do a more like a dot point style underneath the irrationals. So a reminder that an irrational number is a number that can't be expressed as a simple fraction. It's not a whole number, it's not a fraction, it's not 2/5, it's not 7/9. Now, if you sort of rack your brain, you might come up with something, but you've come across at least one irrational number before. And that is pi. Pi is pretty special because it is approximately 3.14159.265 ... And it goes on forever and ever and ever and ever. And what's special about it is it never repeats. Okay, so it's not a recurring decimal. It's not a terminating decimal. It's just a decimal that goes on and on and on and on forever. Randomly jumping from number to number to number. This is actually called a transcendental number. I'm not going to write that down. Transcendental number. Another one that you'll meet later on is the letter E, which is 2 point something. 2 point something. ... That's another transcendental number. We'll use that, and we'll use it quite a bit, both in maths methods and maths specialists. Okay. Probably the more important irrational number, and the thing you're going to spend a lot of time on, is what's called surds. Okay, surds are a number underneath what's called a radical sign. So it could be the square root of 2. It could be, let's make that a little, could be the cube root of 11. It could also be, let's just do one more, the square root of 23. Okay, that's what a surd is. What a surd definitely isn't is the square root of 4. Because the square root of 4 can be simplified to just the number 2, and then it's not in this category, it's actually in the integers category. So it's definitely not the square root of 4. We're going to spend a lot of time on surds, but here, at the moment, there's our whole real number classification. We can talk a lot more simply about things. Forgot one thing. Positive integers are so important that instead of just writing z plus, sometimes, often, we just use the letter n to stand for natural numbers. Real number classification, done.